Hello everyone. In this video, we will discuss about the shear stress and Reynolds stress. A relationship between two physical quantities is called as constitutive relation, and stress strain is one of the example of constitutive relation. And this relation should be frame invariant, which means that any observer moving or rotating in any frame of reference should not matter. So we will discuss about Newtonian fluids only. If the fluid is at rest, then there are normal stresses in the fluid because of pressure that we can write in this form. Because negative sign is here because pressure acts inwardly, then it is taken positive, and tau ij if acts outwardly is taken positive. Then this part is called as isotropic stress because it does not depend upon the orientation of surface. If the fluid starts moving, then additional stresses because of viscosity are generated, which are written in terms of sigma ij. Then sigma ij is taken proportional to the velocity gradient, and this velocity gradient can be divided into two parts, one being the symmetric part and another being the antisymmetric part. So symmetric part is frame invariant and try to deform the fluid particles because each stress part try to deform the fluid particles. Whereas the antisymmetric part is frame variant and try to rotate the fluid particles. That is why it is the symmetric part which is frame invariant. It only contributes to the sigma ij. So we can write that it is the symmetric part, that is Sij, that is only contribute to the sigma ij. So sigma ij is a second order tensor. Sij also is a second order tensor. And to satisfy the condition that sigma ij will be 0 whenever the Sij is 0, it is connected or related to a fourth order tensor. Thus, Kijmn being the fourth order tensor will have 81 components. Then what is the meaning of these 81 components? So we try to explain that one. So here sigma ij being the second order tensor, we can write into a 3 by 3 matrix. And from our relationship of stress strain, we can write that one component of stress will be directly proportional to the strain rate. It will also be proportional to S12 part and so on up to S33 part. So thus 9 components of stress will be directly proportional to the all 9 components of strain rate, making it 81 components for the this game. Okay. But generally, if the fluid is isotropic and symmetric, then it will boil down to a simple form. Thus, for isotropic case, this fourth order tensor will be written in terms of lambda, mu, and gamma, which are scalars. And as sigma ij is symmetric in ing, therefore k will also be symmetric in ing, that we can write kijmn equals to kjimn. Okay, which will lead to a condition of gamma equals to mu, and our sigma ij will be simplified to mu sij lambda sm delta ij. So this mu is dynamic viscosity and lambda is a constant in the bulk velocity. So we have only two constants, which are lambda and mu, out of 81 components if we have condition of isotropic and symmetric case. Therefore, we can write sigma ij equals to 2 mu sij plus s lambda smm delta ij. And this is further simplified for an incompressible case because in that one continuity equation will be 0. That is why smm will be 0. And this will be the final shear stress form. In next video, we will discuss about the Reynolds stress and how that is related to the molecular stress.